Alright, the chem test encompasses stuff that's on the honors, but the honors has more than what's on the regular chem. So I'm going to go through some of the regular chem, then I might switch to the honors chem one, go back. That way everyone gets something. So you should have your reference sheet out. It looks like this. This is the sheet that you guys can use on the final. It's the only sheet you can use on the final.
How much is in yours?
Well, that's because I copy and pasted it, like I cut and pasted, so it was all on one side. Alright, so this is all you get to use on the final, but you do get to use anything you write on this. Okay? So first thing, wow. Okay. First thing we're going to go over is light and electrons. So that includes our quantum mechanics. So a reminder, when we fill our orbitals, it's going to go 2s2, then 2p6, 3s2, 3p6, 4s2, 3d10, 4p, 5s. Okay? So this is the chart. You guys probably remember this from when we did it. And then this is written out the order. If I said, you know, give me the last electron for uranium, then you'd have a big old sentence written out like this. An example question of that would be an atom has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p5. How many valence electrons does it have? So when we look at valence electrons, you're going to be looking at the last s and p orbitals. So if this was 7s2 and 7p4, how many valence electrons would it have? How many? 6. So you're only looking at the highest s and p orbitals. I'll give you guys a minute to write that down. Alright, do we have any questions on this part? Okay, so the next part for regular chem, and this will also be on the honors chem, all of this will be on the honors chem, is we need to know our electromagnetic spectrum. Over here, the bigger the number, the longer the wavelength, the lower the frequency. So we have gamma rays, X-rays, UV rays. Those are all high energy, shorter, higher energy waves. Gamma rays have the highest energy and the shortest wavelength. In the middle here we have our visible light. So that's our rainbow colors that we actually see. Purple has the highest frequency because it has the shortest wavelength. So that means you can get more wave peaks in a certain amount of time. Red is the longest wave, the visible light. And then we have infrared radiation, that's heat waves, microwaves, radio waves, low frequency waves, and extremely low frequency waves. Generally, we stop at radio waves for when we look at this. So if I asked you what was the highest frequency visible light color, what would you tell me?
Purple.
Purple. And conversely, the longest? Red. Any questions on this? Yes?
Are we gonna have to know the frequency numbers?
Nope.
Or just?
So as the frequency of light increases, frequency means how many waves you can get in a certain amount of time. The wavelength does what? Increases, decreases, remains the same. The wavelength decreases. Alright, sodium quantum numbers for the electron, for the last electron in sodium. So we have sodium. And remember our first slide? We have, what row is sodium in? Yes?
We need to know the order of like gamma rays and stuff from radio waves. We need to know the order.
We need to know what happens to the wavelength. Alright, so we have sodium. Quantum numbers. Those are the four numbers that give us the address. So for sodium, what are the four numbers for the last lecture? That's going to be where sodium actually is on the periodic table. So the first quantum number is what?
3,
The row. And sodium, yes, is in row 3. Now, is in an S block, a P block, D block, S block. So what number does the S block get?
0.
0. And if it's 0, what is automatically the next number?
0.
0. Because it doesn't have more than one orbital, suborbital. So it's only going to be in that one circular orbit. And then, is it the first or second electron? So when we fill them, we fill 3 positive spins and then 3 negative spins. So we just do positive first. So what's the last number? Are we positive 1/2 or negative 1/2? Positive 1/2, because it's the first in that row. So that would be the quantum number for the last electron in sodium. Questions?
What are the other, like for the second number, what are the other ones? Like P equals 1, and then what is D equals to just 2?
Alright, any other questions? Yes.
Can you use the 1s, 2s thing to figure out that?
No. Alright, next thing we're going to look at is wavelength and how the energy goes with this. So this is a Bohr model. And we have each ring is our principal quantum number, so our levels. So this would be equivalent to our first row, which only has 2 electrons in it, our second row, our third row. So when this absorbs energy, it pops an electron up to one of the upper levels. When it drops down, it releases the same amount of energy in the form of light. So that's how we get our light. The equation for calculating the energy required, E equals HV. So if I asked you, what is the energy released from a wavelength of light that has a frequency of 5 times 10 to the negative 14th hertz, this is what you would use. Because we have energy H is Planck's constant. And then V is our frequency. And